Hi guys, I hope you are doing extremely well. So today we will discuss another very important problem. The problem number in the Leetcode is 22 and it is known as generate parenthesis. So when we discuss this generate parenthesis problem, today we will be learning another technique to solve this problem. So this is I'm discussing for the first time here. So we will be solving and we will be learning a algorithmic solving technique that is known as backtracking. So we will see how to solve this question using backtracking, right? So before going to the solution, let's see the question first, and after that we will see accordingly. So what the question says, so given an n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So what does that mean? If you see the example 1, the number of parentheses is being given n equal 3, right? So see the output. We have to generate such kind of parentheses which are well formed. So well formed means these parentheses should be balanced. How can we do the balancing thing? So see, if there is an open bracket, then there should have one close bracket. So this is the main condition. If there is 3 open brackets, there should have 3 closed brackets as well. So that is the main thing that we have to taken care of. So now see, for n equal 3, there are many possibilities, like we can form a well-formed parenthesis like this structure. We can form a well-formed parenthesis like this structure, this and this. So these all are correct. So now let's see how can we solve this problem. So before jumping to the solution, I would just like to give you a small introduction regarding the backtracking. So backtracking is a technique that is based on algorithm to solve the problem, right? So it uses recursive calling to find a solution by building a solution step by step, increasing its value with respect to its time. So there are 3 types of problems that we can use backtracking to solve. So problems like decision problem. So decision problem can be solved using backtracking. So here we search for a feasible solution, which is the most feasible solution when we draw a recursion tree. So second, we can solve problem like optimization problem. So in this, what we will do, we search for a best solution. And third category, that is enumeration problem. So what we do in this category, we find all feasible solution. So if you carefully observe, in our problem, what we will be doing, we will be generating parentheses based on decision. We will be taking some decision, like whether we can add an open character, whether we can add an closed character to make the parenthesis well balanced. So every step we will be adding an open character, either open character or closed character. Alright guys, so let's see the decision tree, how we can solve this question by drawing the decision tree. So initially what we can take, we will be having one empty string. So take open would be 0, open brackets would be 0, close bracket would be 0, and number of valid parentheses should be take n is equal to 2. So this is our initial step. Let me write this initial step. So before going to see the different steps, let's check this condition, that whether string dot length equal to 2 into n. What does that mean? So if our string length, if we are given the n is 2, it means we need a output like let's consider this can be our output and this can be our output, because we are having two strings where each parentheses are well formed or balanced parentheses, because if you see carefully, the number of open brackets are 2, number of close brackets are also 2. So 2 plus 2, how many total brackets are present? 4, right? So what is the length of the string now? The length of the string is as the length is equal to 4, right? So if you do the multiplication of 2, means that if we are given the number of well parentheses should be n is equal to, and you are doing the multiplication with 2 into 2, which is again 4, right? So this satisfies the condition as dot length equal 2 into n means 4 equal 4. So what does that mean? That this condition will give us a balanced parenthesis. So we are sure that if this condition gets satisfied, then we will be getting a balanced parenthesis. All right. So now let me remove this. Now we will check how can we take decision in each and every step. So initially we have taken one empty string here. Our open count, the count of open brackets is 0, count of close bracket is 0, and number of parentheses we need is 2. So now check. What can I do? First of all, we can add one brackets here. This should be starting from open. The bracket cannot be starting from close, right? So if you started from close, then it will not form any, it will violate the condition of balanced parenthesis. So the brackets should be starting from open, and we are taking one open bracket here. So let's increase the count of open brackets. This should be 1 here, and close bracket would be remaining same. This should be 0, and number of total parentheses that is needed 2, right? So here, as I have said, that if you cannot start it with an close parenthesis, close brackets. If you start it with a close brackets, then it will violate the condition of well perform or balanced parenthesis. That's why we will be discarding these steps from here. So we will not moving to the other step. So let me go to the next step. So now see, from this step, what are the other decisions that we can take? So either we can add another open brackets here, right? And let's increase the open brackets count. That would be updated to 2. Then the close bracket will be remaining same with 0. The total number of parentheses needed 2, right? So here, what can we do? We can add one close bracket as well. So let's do that. So we will be adding one close bracket here. Then here opening bracket, the count of opening bracket would be 1, the close bracket count would be 1, the number of total parentheses needed 2, right? So far we have we got these two condition, these two solution for this step. again again take decision from this step as well, this step as well, and this step as well. So you can take decision from this step as well and this step as well. How many decision? We will be taking another 2 decision. So now if you carefully observe here, if you add another open brackets in this decision in this step, so it will again violate the condition of n equal to. So what it will give us, as we are given to find n equal to balance parenthesis, so if you add another open brackets, then we need another 3 close brackets. So this should be false for n equal 2, but this will be true for n equal 3. But here we have taken only 2, that's why it violates the condition of balance parenthesis. So now discard this step from here. This will not take decision here, so we will discard this step from here. So now again check. What can we add here? There is a chance to there is a possibility to add one close bracket here. So as we are having 2 open brackets, so we can add one close bracket. So if we add one close bracket, then our open brackets will be remaining same to 2, and our close bracket count will be increased to 1, and total number of brackets is given 2, right? So this is our updated step. So again check for this one. So this condition, what can we add? Here we can add one close here you can add one open brackets. So these are all form. So again we need another one close bracket and one open bracket. So first of all add the open bracket here. So now updated this to 2, and close bracket would be remaining 1, and our total step would be 2. So now again check for this condition. This will again violate the property of n is equal to, because if you add on another open bracket, then this will as I have said that we need 2 balance parentheses. So again we will be discarding the steps from here. So what is remaining? This is remaining step, and this is our remaining step. So now here what can we do? We can add one close bracket here, then our open brackets will be 2, close bracket will be 2, number of well balanced parentheses is needed 2, and here what can we do? Here we can add another close bracket. So this would be our close bracket, then our open bracket equal to, close bracket equal to, number of bracket is needed 2. So now see, if you carefully observe here, what we got from this step, we got our output, right? Because this parenthesis is well balanced, this parenthesis is well balanced, and our input is given, number of parentheses is needed 2. So the output would be looks like this one string, and sorry this should not be come here. Output would be looks like this string, this would be another string. The structure of the strings is different, but both of these strings are giving us a well balanced parenthesis, right? So we are done with our solution. Now also check this thing, this condition, that our string dot length is equal to 2 into n. So see does, and what is the number of string length is 4, and what we need, the n is 2, so it is also 4, so 2 equal 4, so this is also satisfy the condition. So now let's see the coding part, and I will discuss every steps in the coding part as well. Okay, so let me go to the coding. Yeah, so now see, as we are aware of the recursion, what we have to do, we write one helper function, right? So this is our helper function in this code. So in the helper function, what we have taken one list to store the parenthesis, one string, one open bracket, one close bracket. So this is not one, just I have taken as a parameter. So this should be the number of open brackets, number of close brackets, and this max is the total number of balance parentheses that will be given in the input, right? So as in the decision tree, I have shown that we have to maintain this condition. What this condition is says, if the string length equal to the max into 2, then add this string to this list. Alright guys, so now see this condition, open less than max. So open less than max, I have taken this n as a max, so n is given us 3. Let's consider this example, n is given is 3. Yeah, let me do these things. N is given is 3, and our open less than max, what could be the condition open less than max? So if the open bracket is 2 and if open bracket is, you have drawn that open bracket is 2 and you need to balance your parentheses, n is given 3, so we need 6 brackets, right? There 6 would be, 3 would be open, 3 would be closed. So if we are getting 3 open and 3 closed, then that time we can say that our parenthesis is well balanced or well formed. So if your open bracket is less than 3 or 6, then there should not have any possibility to get the well balanced parenthesis, right? So that's why you have to increase the open count, open plus 1. So we have to increase this to 1, that will be added here, and just pass this close and the number of parentheses you needed. And the second condition, close less than open. If condition like, if your open is 3 but your close is only 2, and this case also it violates the property, right? So violates the property of well balanced parentheses. So that's why if this is the case, if our open bracket is 3, we should have to add another close brackets here to get the well balanced parentheses. That's why we have added close plus 1. So now after doing these things, we just call the backtrack here and we have written the list. Alright, so I hope you understood this question and the solution. So let's quickly discuss about the time and space complexity. Time complexity would be 2 to the power n, and the space complexity would be order of 1. It should be order of 1. So why this time complexity order of 2 to the power n? Because since at each index we have 2 possibilities, right? Either opening or closing brackets. So that's why the total time complexity will be 2 to the power n, and we have not used any auxiliary space. That's why the space complexity would be order of 1. So that's all for today. Just in case you have any doubts or query, then please feel free to ask me in the comment section. We'll meet in the next video. Best of luck and thanks for watching this video.